Hey, welcome back. In this video, we're going to talk about jumping and how this is going to involve action mappings. Now, these are similar to axis mappings, so we'll look at these and see how they work. Now, we're going to talk about the character movement component, that special component that belongs to the character class that determines how the character can move around. So let's talk a little bit about action mappings. Now, just like axis mappings, action mappings allow us to map some sort of input to gameplay logic. So if we create an action mapping called jump and link it to the spacebar, then an event called input action jump is automatically created and available from within the Blueprint event graph. And as soon as we hit the spacebar, this event gets fired off. Now, action mappings differ from axis mappings in that they are not being called every single frame. An input action event is only called as soon as the key associated with it is pressed. So these are more like one-off actions that don't require a constant inflow of information. So let's set up an action mapping. Now, I can get to the action mappings from the project settings. So we can go to Edit and Project Settings and scroll down to Input. Now we see under Bindings, we already have our axis mappings, but just above that, we see action mappings, and I can click the plus to add an action mapping and expand the dropdown. And now I have this new action mapping 0. I'm going to rename this to simply jump. Now we have the dropdown and we can select different types of inputs, but I'm going to use the shortcut by clicking this keyboard keys icon and hitting the spacebar on my keyboard. And now the spacebar is linked up to this jump action mapping. So now that we have a jump action mapping, your challenge is to implement jumping. Open the character blueprint and use the input action jump event. Now hook up to the execution wire a jump node. Jump is a node that already exists in the character class, so we can access that and use it when we press the space key. So go ahead and pause the video and implement jumping now. Okay, so I'm going to close the project settings and open my FPS character blueprint. And just below these nodes, I'm going to right-click and type jump. And I see that there are lots of options here, but the thing I'm interested in is the action event. So if I click on this, I see the input action jump event. Now we have 2 output execution pins as well as a key value. Key is a special data type the Unreal Engine uses to identify which key we're pressing. Now we can link up logic to whenever our spacebar is pressed and when our spacebar is released. We're interested in when the spacebar is pressed, so I'm going to drag off of this and type jump. Now we have a blueprint function called jump. I'm going to select that, and this is the jump node. And implementing jumping is as simple as that. So I can compile and hit play. And now clicking in the viewport to get control, if I hit the spacebar, I see that I am jumping. So Unreal Engine's built-in jump function already handles everything that we need when it comes to jumping. Okay, so we have jumping. Now, when we're implementing blueprint logic, it's sometimes useful to add comments to our code. For instance, we have these move forward and move right input axis events with our move forward and right functionality. I'd like to keep these sort of bundled together in their own little group with a descriptive comment. And I can do that by left-clicking and dragging so I can select all of these nodes and hitting C on my keyboard. Now I'm prompted to write a comment, and I'm simply going to type character movement. And now if I zoom out with the mouse wheel, I see that these nodes are all grouped in their own little section here. I'm going to do that with our turn and lookup axis event logic as well. So I'm going to drag and select all of these nodes, hit C, and I'm going to type mouse input. Now I can scroll out and move these over next to this other group. Now, these grayed out nodes are not really being used, and we can always get them later by right-clicking and typing the name of the node. So I'm going to highlight these and remove them with the delete key. Now when I zoom out, their comment messages aren't overlapping with my logic. Now, the last thing I have down here is my jump logic. I'm going to highlight that, hit C to comment it, and simply type jumping. And now our blueprint event graph is nicely organized, and we know exactly where to look when we need to get character movement, mouse input, or jumping logic. Now, the last thing I'd like to talk about is the character movement component. You see, when we called jump, the character automatically jumped. But what if we'd like to control the way the character jumps? For instance, what if we'd like to jump high enough to reach the roof of a building or something like that? Well, when we call the jump function, the engine looks into the character movement component for this particular character to look at the variables there, which should determine how to move the character. Now, there are lots of variables here, so we're only going to touch on a couple. But I encourage you to dig into these and see what happens when you change certain values. So we have this gravity scale, and this affects how gravity affects our character. If we set this to 0 and hit play, then when I jump, I'm not coming back down, and that's because gravity is no longer affecting the character. So we're definitely going to want to have at least a value of 1 for the gravity scale. And if you increase this, then the character is going to fall more quickly as gravity is stronger. Now, max acceleration affects the rate of change when we're moving in the world. It's set to 2048, but if we set this to 0 and hit play, now when I press the keys, I'm not moving at all. Now, if instead of 0, I set this to a very high value, such as, say, 10,000, now when I hit play, my character reaches its maximum speed almost instantly. So an acceleration value allows us to smoothly ramp up from 0 to our target walk speed. I'm going to put that back to 2048. Now we have a braking friction factor, and this determines how we slow to a stop. If I change this to 0, then as soon as I stop pressing the W key, I sort of slide to a stop. And of course, if I were moving more quickly, then that slide would be more dramatic. So if you want more friction, you can increase that value, and you won't slide to a stop, but rather stop more abruptly. Now, we have a number of other parameters, but I'm going to zoom on over to the walking section, and we have some variables here. Max step height determines what sorts of structures we can step onto. If a structure is taller than 45 units, we would not be able to step up onto it, but we can increase that if we'd like to step on higher structures. Walkable floor angle determines how steep of an angle something can be for us to still be able to walk on it. Now, I'd like to show you a quick example of that. If we click on Starter Content, and here in Starter Content, we click Shapes, and we drag in a shape such as this shape quad pyramid. I'm going to drag the pyramid over here and hit the R key so that I can scale it up. Now, this pyramid is quite steep. So if I hit play and attempt to, say, walk up the side of this, I will fail to do so because it's just too steep. But if I go into the character movement component and change the walkable floor angle to a higher value, such as, say, 80 degrees, then if I hit play, then I can suddenly walk up the side of this pyramid. So that is something you can configure if you'd like to have more control over what sorts of structures you can walk up the side of. I'm going to go ahead and stick this back down to what it was before, which was just below 45 degrees. I think it was 44.5 or something like that. And that way, if something is 45 degrees, we consider that too steep to walk up. Now, ground friction also affects how we slide on the ground. If we lower ground friction to, say, 0, then I'll be sliding more to a stop when I stop moving. And we can really see the effect of this if we change the max walk speed. By default, max walk speed is 600. If I change this to about 3000, however, then I see that I can smoothly ramp up to a very fast speed. And if I stop moving, I slide quite a bit. Now, changing the ground friction is going to affect that. So if we change ground friction to, say, 20 and hit play, then I can ramp up to a high speed, and as soon as I stop moving, I've stopped almost instantaneously. So ground friction is another variable we can play with. Now, if we leave our ground friction at 8 and our max walk speed at 3,000, we can change our max acceleration to, say, 30,000. Now when I hit play, if I start moving, notice I don't ramp up to my max walk speed. That's because my acceleration is so high that I can reach my max walk speed very, very quickly. I'm going to reset that back to 2048, and I'm going to set my max walk speed back to 600. And that way we have these sort of reasonable, normal values, but you could always change those if you want different behavior for your game. And I'm also done with this pyramid, so I'm going to go ahead and select it, hit delete, and remove it. So in summary, we've added a jump action mapping, and we linked that to the spacebar key. And now we are jumping thanks to the built-in jump function blueprint node. We also looked into the character movement component and tweaked some of the variables to see how they affect our character. And now we know that we have a great deal more control over how the character can move throughout the world. Excellent job. We now have movement. We're ready to start implementing some of the shooter mechanics for this game. I'll see you soon.